Hello, I'm Eric Snodgrass, and thank you for watching today's long-range forecast video brought to you by Nutrien Ag Solutions. This analysis is being provided by perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that all long-range weather forecasting is speculative by nature. Well, this particular video is going to be broken up into two parts. The first part is going to address longer-term drought. The second part is going to take a look at what we're looking at over the next 3 to 4 weeks. I got a couple of great questions over the last week traveling the country talking to farmers, and those questions keep coming back to this idea of this 89-year drought cycle. And so I want to talk about that because some of the questions are we looking at a complete reversal of 2019? Are we going to have a super hot and very dry summer? Last time we had that here in the midsection of the United States was back in 2012. And so you've been looking here at a map showing the U.S. Drought Monitor back on July 31st, 2012. We have these 5 stages of drought, and you can see them color-coded right here. Keep that in mind. Now, one of the first questions we often get asked is there any sort of preseason indicators that drought can expand? And I'm just going to make one kind of point here. Now, this beginning analysis is going to primarily focus on this region. I'll just generally call that the Midwest, okay? Normally, if we're watching drought coming out of Texas or out of the Four Corners states, and it's the middle of winter and that drought is expanding through the beginning of spring, we do need to be concerned about its ability to migrate north and east with time. Secondly, if there's drought in the southeast that starts off in spring, a lot of times during summer, the Bermuda High will slide over here, expanding this drought into the Ohio River Valley. So we have to watch for drought to move, and those are the regions that we typically watch for it to move out of into the midsection of the country or into the eastern part of the country. So just again, what you looked at here, this is January 31st of 2012, and what I showed you what was July 31st, 2012. But let's come back to this idea of Midwestern drought. So from the U.S. Drought Monitor, we have weekly drought monitor information going back to the year 2000. This graph shows you the percent of area in the Midwest, so from 0 to 100%, that's covered in different stages of drought. So when you look at this, that lightest yellow color is the first stage of drought, all the way to the darkest red, which will be the 5th stage of drought. Now, one thing to make sure that we remember about drought in the central part of the United States, because of the way our weather systems work here, where we don't have a distinct wet season versus a dry season, drought typically doesn't last in terms of its greatest extent more than about 6 months. We often see that drought begins in the middle of summer, right in through here. You can see some of these years, especially this is the one of 2012, where the drought really got going by the time we got into June, July, August. Here's another thing to think about with this. Notice that since 2012's peak, where up to 80% of the Midwest was covered in some stage of drought, we have since then seen very few events that have covered a major part of the Midwestern United States. This is 7 years of data here, where we've seen very small pockets with drought, but nothing expansive in the Midwest. Now, I want to compare and contrast that to what's going on in the western United States, where because of its Mediterranean-style climate, with a distinct dry season that typically lasts from April to October, drought has the ability to persist. So when we look at California in particular, we can see the drought from 2001 to 2005 showing up, with the distinct break in 2006. Then from 07 to 10, with a distinct break in 2011. And also here from 12 all the way, really from 13 all the way to 17, with again a distinct break. So we need to make sure that we see the United States and where the Rocky Mountains divide the U.S. as having two different broad-scale climate regimes. So keep that in mind as we go forward with this. Now, the question that I've been receiving is about this 89-year drought cycle, and I've did a little bit of research to figure out where maybe some of that rhetoric has been coming from. And it seems as though there have been a few publications and journal articles that, not necessarily from the peer review, but from atmospheric scientists, meteorologists discussing that there's some sort of correlation between sunspot activity and drought, especially drought in the central U.S. and the Midwest. So up there at the top, you've been looking at a graph that shows you sunspot cycles. And what are sunspots? Sunspots are basically these small regions, well, compared to the area of the sun, but small regions on the surface of the sun that show up colder, but quite a bit more active in terms of solar activity. So they're a few thousand degrees colder than the rest of the surface of the sun. There's a very well-established 11-year cycle in the sunspot activity, and that's what you see up here in this blue line that kind of goes up and down and up and down. And again, that graph there goes back about 400 years looking at sunspot cycle activity. So what do we need to know about this is, do sunspots and their prevalence control our temperature patterns, and do they control our precipitation patterns? Now, certainly if I look at this and I remember that the total variance in solar output from a peak of a sunspot cycle to a valley is about 0.1%. The question we have to ask is, does that matter? Does that change our temperature and precipitation patterns? Because an argument has been made by other meteorologists that there's this secondary cycle to the sunspot activity that's running on about an 87 to 89 year cycle that matches up with drought we had in the U.S. back in 1847, the peak of the drought of the Dust Bowl in the 1930s, and then a suggestion that sometime soon we're going to have this massive drought between now and 2025. So we need to think about that and start to ask ourselves these questions. Does the sun and its variance in solar output impact our year-on-year temperature changes? So first of all, if we knew that there was a strong correlation between sunspot activity and our yearly temperature patterns, our temperature patterns would follow the 11-year cycle. And they don't, okay? So then we go and look at graphics like this. Over the last 70 years, especially for summer in the Midwest, okay, that's what we want to focus in on here, from June, July, and August, is there any correlation with our precipitation patterns and sunspot cycles? And I hope what you see here is the answer is no. If there is any correlations, they don't seem to be grouped well together, and the correlations are very weak. What about temperatures? Same time period, surface temperatures. Well, you're saying, wait a minute, I do see the cooler bias there and the warmer bias here. But I need you to look at the correlation coefficients. They're right around here between negative 0.15 and positive 0.15. They're not 0.9 or negative 0.9. They're very, very weak. So my conclusion about our summer patterns and their relationship with sun output, sunspot cycle, and things like that, they are secondary at best, which means our precipitation patterns, which could lead to drought, are not being driven solely by changes in solar output, which is what the argument is on this 89-year drought cycle, okay? I want you to set that aside then and look for other things. So what I did here, this is from NOAA, looks back to 1895, every single year, June through August, total precipitation. I have decomposed this time series a million different ways, and to look for cycles of statistical significance, we don't find them. So you ask, well, we had this drought in the 1930s. I've circled it right down here. What caused that? Well, there were a lot of things that came together during the 1930s to make this happen. One, the North Pacific was very cold compared to average. The North Atlantic was very warm. Two, we had during this time period some very interesting agricultural practices happening in the midsection of the United States, the Central Plains, in that we had a common thought back in the 1930s that any time that we were in a period of drought and we got some rain, we should go plow the field to turn the water over and store it in the soil. Well, we know that that actually increases evaporation and enhances a drought. We don't have those practices anymore. That is not, though, the sole cause for the increase over the last 70 years in summer precipitation patterns across the middle part of the United States. And the drought years we do have, you can see them down here in summer. There's no cycle to them that is easily discernible from the data. So what causes drought, I've highlighted at the top. It's anything that can block the weather pattern. Now, what does that mean? It means this. I grabbed our driest years in the midsection of the United States and made a composite map of them. And what we notice is this. Keep an eye on Alaska and Greenland. What we see is that during summers, where there is extensive drought in the midsection of the United States, we tend to have troughs of lower pressure that sit over Alaska and Greenland and large ridges setting up right in the midsection of North America. Now, what are the influence of those ridges? Well, first of all, when they happen, the global winds slow down, and right over us, right in the midsection of the United States, we tend to get slower jet stream winds. And the slower the jet stream winds become, the more highly amplified they can move. And what does that mean? They tend to meander much farther to the north and to the south, versus what we have right now across all of North America, which is a very fast jet stream. Okay, so let's see the differences here. What happens is the total wind flow in the upper levels of the atmosphere tends to sit and spin like this, and it blocks everything up, And then the drought tends to reinforce itself, meaning that what caused it, the blocking weather patterns, the heat, the high evapotranspiration rates, then feeds back positively on itself, causing it to happen more and more and more. So we say, are there any lead indicators of something like this happening? And we can take a look at this map, and that is, in June, July, and August, what do our global temperatures look like on the ocean surface? And we see that for those years, oftentimes we get this reverse C shape of colder temperatures that sit from the Gulf of Alaska, come through the Baja of California, and extend south of Hawaii, with warmth tucked away inside of that. Now, we can make an argument that this is the negative phase of the Pacific Decadal Oscillation, but there's more to it than just that. So if there's any sort of preseason indicator throughout April, May, and June, I want everyone to be watching the ocean temperatures off the west coast of the United States. If they're trending colder, that could be an indicator that we could block up our summer weather patterns. But my story here is to tell you that this will not be driven by sunspot cycles and an 11-year or an 89-year cycle. It's other things that dominate our weather patterns in summer. And in the Midwest, because we know drought duration is so short-lived, we have to be looking on much shorter timescales to find it. Now, I want to show you this and then immediately show you this. This is the current projection from the National Multi-Model Ensemble. And what this is 7 separate models in the United States and Canada that are put together to give you a forecast of ocean temperatures. Now, you notice the blue showing up in here. And you might stop and think, well, maybe we do have a bit of a La Nina-like summer ahead of us. But remember, a lot of times when we have La Ninas, strong La Ninas, the cold water extends almost everywhere inside of this little wedge that I'm drawing here. So this would all show up as cold. Now let me get that drawing off there so you can see a little bit better. Right now we're noticing that the North Pacific is showing up warm, as is the North Atlantic. But what I want to be very careful of here is looking at the gradients. Having a great discussion this morning with my fellow meteorologist here at Nutrien, we were talking about how the fact that in this area here, you do notice that our temperatures are closer to average. If we watch that area carefully over the coming months, and we do notice near average temperatures in here that possibly get even a little bit cooler, that's one sign that we may look toward a drier summer. But right now, don't leave this video thinking that I'm saying that that's going to be the case. I'm telling you what to watch with me. The fact that the North Pacific, though, right now is showing up quite warm is another indicator that we would resist having extensive ridges developing in the midsection of the country. So this is not a slam dunk by any stretch of the imagination. I'm just telling you what we as meteorologists are going to pay close attention to. Here's another thing we have to consider. For the Corn Belt, which is what I'm focusing on initially here, for the Corn Belt, we've noticed that since 1948, so 70 years of data would suggest that the longer-term trend is toward a wetter growing season, April to October. How much? Well, if you compare the bottom of that trend line to the top, it's over 5 inches of additional precipitation, which means for summer to become very dry would also have to buck a long-term trend. The atmosphere can do that. It did it in 2012, so don't think that it can't. What I'm telling you, though, is the probability of that happening is reducing with time. This is the systematic longer-term change in the climate right here in the midsection of the United States. We can add it to this. Now, this is an interesting figure. There is a data set, high resolution, that goes back to 1981. So it's about a 40-year-long data set. What I did in this map is I took 1981 to 1999 and added up all the precipitation. I stopped, and then I added up all the precipitation from 2000 to 2018. I then subtracted the total precipitation from the second 19-year time period, 2000 to 2018, from the first, 81 to 99. And then I divided by 19. When you do all of that, what we find is the average annual difference in precipitation over the last 40 years. And we do notice that this section of the United States, the Ohio River Valley, has been getting wet, as has much of the Mississippi watershed. In fact, almost everywhere east of the Rocky Mountains has shown a wetter bias. This is a tricky map to diagnose if you come down here to the south because of hurricanes. But I want to also let you know that I have not yet fully researched why Oklahoma is showing up drier. There could be a lot of reasons for that, and I don't know them yet. But you do notice that west of the Rocky Mountains, we have the opposite pattern, where things are going over toward drier conditions during that time period, or comparing these two time periods. We need to keep this in context of the current forecast. So here goes part 2. Over the last month, it has been very dry here. We need to ask ourselves why, and then ask ourselves if it's going to persist. We've had pockets of dryness in the Intermountain West, and then remember, if you kind of slice this part of the country off, coastal Carolinas, southern Georgia, and Florida have been very, very dry as well. Midsection of the continent here, though, we've seen anywhere between 150 and some places up to 300 and 400% of normal rainfall and snow. So we right now have a pretty sizable surplus of moisture in the midsection of the United States, while the West has been dry. All of our reporting stations out of California, well, if this is the way that they're normally accumulating precipitation during the wet season, we're currently sitting right down here because of how dry January has been so far, which means February and March are going to have to shift to get us back over into that wetter regime. So we right now have a deficit in soil moisture in this part of the country and major surplus here. Now that surplus that you see there is more than likely going to be around until we start spring, which means the spring flood fight up here in the north central plains is going to be real, given that we have an excess of 4 to 6 inches of water underneath frozen topsoil. But getting down into the mid and lower Mississippi River Valley and the Ohio River Valley, we're also quite wet as well. Where our drought currently sits is down here in southern Texas and in the Four Corners states. So let's keep an eye on all of these regions. It's also very dry down here in Florida as well. Let's keep an eye on all of it as we progress through spring, because this will be the actual starting factors that will determine what will happen late spring and summer, not the sunspot cycle. So in our near term, over the next 10 days, these are the dominant features. We see that the jet stream starts here off of Africa, races across India, China, and then ends up in the Central Pacific before splitting into a northern branch here and a southern branch that does this. Now, what is the consequence of a pattern like that? Well, in terms of precipitation, it's tending to direct all of the wetter weather around a big ridge that's setting up here. Now, that's going to keep California, which I just showed you is already dry for at least the next 10 to 15 days compared to average. It's going to crank up the subtropical jet stream here, keeping the southeast on the wetter side of things, but also warmer. And why are we showing up with a slight dry bias here? It's just because as the jet stream comes together in this area, this is not a region where we have great upper level support. Our low pressure systems are developing east of here and racing on off in this direction. That's the meteorology of that flow pattern. So is there going to be any systems coming through the midsection of the country? Of course there are. But is it going to be anomalously wet? That's what we're trying to answer. Let me just fast forward you to give you a little bit of short term here. I'm out on the 4th of February. We've been watching very closely for the development of a low somewhere in this vicinity, out ahead of which plenty of moisture coming in around this high and enough on the backside to be getting some snow. We don't have any details on this system. Again, this is midweek next week, about a week from right now. And we do see, though, that the models are saying, hey, the chances of getting some snow on the backside of this are good. But look out west. Where's your biggest snow? It's coming into British Columbia. It's coming into the Cascades and the Northern Rockies. And we're not adding a lot of it to the Sierra Nevada to the south here. And that's critical for this time of year. We need that snowpack. So, stretching it out longer term, this is what the month of February is looking like with the latest European weeklies. And I've seen some consistency in this. That split flow seems to be dominating what we've been noticing here in the flow pattern of the atmosphere, and it has a tendency to keep California dry, and that's not good. Remember, even though you see the dry bias in through here, we could still see, and we will see, a return toward what could be normal winter conditions, some snow in this area, and regular weather systems, but a slight dry bias just because the atmosphere is not in the best configuration to really crank up low pressure systems there. By the way, to show you what that would have to be, the jet stream would need to be doing that. Trough here, then we crank that up. By the way, what I just drew for you there was what we had all last spring, okay? We're not there right now. It's a different pattern. It's split, okay? So let's now talk about temperatures. Right now, we've seen since mid-January our global wind anomaly really crank up, and it stayed above normal. What does that mean? That tends to give us a much faster jet stream. That tends to be more zonal jet stream. That tends to give us a more relaxed pattern across the lower 48. And over the last month, we've seen warmer than average conditions well tucking into the eastern half of North America, with all the cold up in Alaska and over Greenland. So we've seen this cold air at times leak out of this area, come all the way down to the southern tip of Florida, but no long duration cold spells in a while. In the near term, Is the polar vortex changing at all? Well, today, right now, it's sitting and spinning very tightly here. Remember, the stronger, more stable the polar vortex, the less likely you are to get big dumps of cold, bitterly cold air as the stratosphere and troposphere kind of connect. We see that getting out to about day 7, the polar stratospheric vortex might stretch out. But then by the time we get to day 10, it's going to try to reform again, sitting somewhere over Siberia. And because the Arctic oscillation keeps staying in this positive phase, temporarily stretching here, but it's never diving down into this area. And so if it stays in the positive phase, that's just one indicator that making a call for long duration, bitterly cold air through the month of February wouldn't be wise right now. Will it get cold? Yeah, it's going to get cold at times. It's still winter. But I'm talking about the brutal cold that lasts for a long time. The Arctic is not playing cards with us in that regard. So what about just looking at the overall strength of the polar vortex? It's currently sitting right up here, whereas a year ago, remember, when it split, it was way down there. We're kind of running out of time as we end, winter and go towards spring to get the polar vortex to really dive down here and make some sort of significant impact on our late winter and early spring patterns. In other words, we kind of lose the ability of the polar vortex to do its very bitterly cold weather patterns as we progress forward. It's not to say that it can't. It's just we've missed the best opportunity, which would have been in December and in early January. Just a point I want to make here. All right, what about this? If we look at Alaska and Greenland, we look for those areas to possibly get blocked up with big ridges to shove cold air into the middle part of the country. Well, to do that, we can look at the EPO. We would need to see it go negative, or the North Atlantic Oscillation, which would also have to go negative. Well, the EPO does appear to come back toward neutral, which means this trough that's been sitting over Alaska seems to be replaced by the time we get out to about day 10 with some ridging in this area. See it there? And that will allow for some, more winter-like normal weather for winter to come out of Alaska through the Canadian prairies at times and down into the eastern half of the United States. And it'll also set up cold in the west as well. But the North Atlantic Oscillation is not helping out, which means we're not shaking the trough over Greenland. And because of that, it's hard to have a combined effect to bring in brutally cold air east of the Rocky Mountains. So when I show you the next 5 days, all the cold air is tucked away here. The pattern's relatively moderate across the lower 48 and warm up here around the Hudson Bay. Days 5 through 10, well, at this time, remember, the ridge starts to build in here. So we start to get some cooler weather out west. But the pattern is, it's just not allowing for deep penetrating troughs to come into this area. So we still hang on to this slight warm bias. It's not warm, but it's just not brutally cold. And then even as we look out farther, I want you to focus on the map on the right. That's the European. I've been explaining that the GFS has had a pretty systematic cold bias. It's trying to let that cold air come out. But return toward maybe some normal winter conditions in the Canadian prairies into the northern U.S., not so much down here in the southern region, but I'll tell you, the GFS has been backing off on its cold and coming much more in alignment with the European. So if you don't mind, I'm just going to do this and say, take a look over here instead. Get the cold setting up here, occasionally coming down, but this pattern, it seems to be in place. So if we finish this video up and say, are the tropics adding to this? Well, we got to get out to phase 7, 8, 1, and 2 to get that colder air to really come out. We've been spending so much time in phase 4, 5, and 6 throughout the month of January. Right now, the MJO is sitting here. In fact, let me draw that in black. And it's coming out. It seems to just hang out in null phase and want to come out in phase 4, 5, not over into this area. So the tropics aren't hinting at a major pattern change either, at least any time in the next 10 to 15 days. So when I see the European weeklies looking out now at temperatures suggesting that, hey, we could sometimes get some cold air coming out of Alaska doing this, maybe building in at times a trough here, I think the subtropical jet's going to dominate for the southeast, keeping temperatures there much more moderate, much more closer to normal, maybe warmer than normal. And any shots at colder air that come through the Canadian prairies and into the Midwest, I think they're going to be short duration. So, we started off this video talking about, our drought situation, and we finished talking about what February is going to look like. And the questions remained, is this indicative of having a drought setting up for spring or summer? And I'm just going to tell you right now, we don't know. And the reason why we don't know is because we have to get through our winter weather patterns into the spring weather patterns, which set up in March, to know what things are going to look like. So sit tight. We'll watch it together, okay? But I wanted to present to you that full kind of spectrum of things as I've been getting so many great questions about it. We're going to stop this one right here. Thanks for watching. Talk to you again soon. Thank you.